Here we are, it's our Kali Linux. We're going to look at a few things. I'm going to go to our terminal because so much in Linux is terminal. And of course, the first thing in this tutorial is a mistake. It's not IP-A.
Oh, yeah.
I keep typing in a dash because quite often, as you notice here, dash indicates an argument. Well, in this case, all by itself, IP doesn't work. You do IP-A, which then shows you your local addresses. So that's why I keep putting a dash in it, because the dash is a common argument. Argument meaning A modifies how the IP command works. And really the only one I've ever done is IP-A. There's a bunch of other ones that you can use, and I'm thinking A is like an alias for address, I bet. Let's try that. Yeah, it is. It's like an alias for address. So when you type in A, it's saying, oh, we actually want address in there. So that's called an alias or a shortcut. Same thing. When you have shortcuts in your desktop to a program, that can also be called an alias. Like one of my aliases is Guillermo, because that's my name, William, in Spanish. And one of Mike's aliases is Mike. And let's see if I can take a chance. Mihail.
Yes,
Mihail.
correct.
Mihail. Okay, that's not too bad. I know the minute you say it, if you say it, I'll be like, oh my gosh, I'll never get this. Okay. So this is an important one as we're dealing with networks in Linux. And Windows, we use ipconfig/all. Well, to find all the network information from the command line, we either need other utilities. If we use the built-in ones, we have to kind of do them a part at a time. So the first one is called the loopback. 127.0.0.1 is the local host or the loopback connection. Its only purpose is my network working? I'm sorry, is the network stack inside of my computer working? So if you ping localhost, you should get a reply because you're pinging yourself. If you don't get a response, there's something broken in your operating system of the part that does TCP/IP communication. So that's the only purpose of this guy. This guy is in even, how I say computer things are almost always numbers starting at 0. Well, of course, here they do 1, 2. Anyway, ETH0 and some distributions of Linux is always going to mean the first Ethernet adapter, and it does start at 0. Even if your laptop is running on wireless, this is still going to be ETH0, which leads to the question, why, if you have wireless on your laptop, would this still say ETH0? I know Mike knows the answer.
I got WLAN 0 for my wireless.
If you're connected, in your case, your Linux is on your physical machine.
Oh, yeah.
So it is connected to the wireless.
Of
Where
course.
VirtualBox.
In the VirtualBox, I have ETH because it's a virtual Ethernet adapter provided by VirtualBox.
And that is connected to your wireless adapter.
Yeah.
Yep, that's why. So this is virtual. It doesn't really exist. It's tapping into whatever network adapter you have to get network access. And one of the things that we want to do is, by default, our virtual machines set up what's called a NAT network, which means in this case, it's like a local NAT network. It gets an IP address. Your machine can get to the internet, but you can't really do much of anything else other than surf the web. We're going to be working with the network on a more extensive basis. We want to use a bridged adapter so that it's, even if you have wireless, it's still going to say ETH0, but your bridged adapter is going to be as if it were your regular adapter. So in your case, yours is going to say probably wireless here. If I was using the wireless on my device for this, I would pick my wireless there. But we want whatever adapter is connected to your local network. And then now we're part of the local network. We're not hidden behind our own little firewall. And it'll take a second because it'll disconnect and then it'll reconnect. Most of the time, these things can be done on the fly and then it'll come right back. Sometimes you have to reboot the machine. Let's just see what's happening. How would we find out if we have a new IP address?
You can see it, IP A or IP-4A
Oh, because of the,
or IP.
for
Yeah.
version 4 IP address.
Mhm.
Now, if you are not ever sure, well, I should just point this out. This is always going to be the address range you get something in if you're on the internal protected NAT of VirtualBox. It's going to be a 10.0.2. Well, now it's getting the address from our local network, 10.0.1, which is D1. Whether you're on Wild West or you're in this room, you're going to get 10.0.1 dot, and in my case, 132. And /24 is the shortcut for, oh, I'm getting E somehow. 255.255.255.0. Well, why is it 24? Because each of these takes up 8 bits.
Mhm.
8, 16, 24. So it's a shortcut notation. You'll see this sometimes, you'll see this sometimes. It just depends on the system and what you're doing, which one you see, but they're interchangeable. And /24 is a very common network address, meaning it's the address of the network, right? This part is the address of the network. This part, 132, is my host address. In anything, before you can protect it, you have to understand it. Understanding networking is very important. So there should be a built-in program, and if there isn't, we'll install it because my tutorials are based on the last time I went through tutorials and that version of Kali Linux. So things will come and go. So sudo means what, Phil? What's happening when I do sudo? What am I doing?
Giving information to do some comment that only the administrator will have access to.
And what's the administrator called in Linux? Excelente. So we're going to run Netdiscover, which is just a little tiny command line program. And if you're not sure how something works, you can do /help sometimes, and it'll come up with. We have to do our root password. There it is. There's all our stuff we can do. Well, this is the one we want. We want range. We're going to scan a given range. Auto scan means that it would figure out what network it's on. And I think by default it does auto scan, but we want to learn how things work. So I'm going to Netdiscover. I'm going to specify my range, which is why I did IPA. And I'm going to do 10.0.1. What is the address of the network? Because
Zero.
Exactly. 0 designates the network. And I can do this 2 different ways. I'm going to do it the shortcut way because /624 is a lot less typing. You could also do it the other way probably, but I like less typing. And, oh, it still works. Sometimes you try something, it works one time, and then the next time you get a new version of Kali, it doesn't work. There it is. That was a pretty quick scan, wasn't it? Yeah. So it's doing what's called an ARP scan. It's sending out an ARP request, and then it's getting information based on the ARP protocol. So you know what I'm going to ask next, don't you? It says so many captured ARP packets. So what is ARP? What does ARP do? What does the acronym stand for? What's the purpose of ARP? Has to do with how things communicate on the network. So my network card, I think it shows up in IPA. My network card has a, there it is. This is my MAC address. So how network traffic works, which again is another thing we need to know about. So I'm going to go to my favorite thing. Oh, no, I can't remember the name of it. OSI model. You took, well, any class, you will have seen the OSI model before. It's a theoretical model to visualize how networks work. So, physical. This is the physical network card in my computer. It's the physical wire. It's the wireless waves. It's the access point. It's anything that you physically connect. But we're all physically connected to the same network. So how do I know how to communicate with, boy, my brain is not working. I just had lunch. That must be why. No, your name isn't Jacob. You're gonna have to help me out. Caleb. Sorry, Caleb. I know who you are. Must be just I had sourdough bread and that must be like taking over my brain. Okay. Anyway, if I want to talk to Caleb, what do I need to find out first? Well, I just found out his name. Not on purpose. I did that. I did that because I did literally forget his name. Then I thought, oh, that's a good way to do it. So what I did is, oh, I forgot your name. And he said, my name is Caleb. So that's the name of his physical connection to the world, which is like a physical connection to the network. Caleb's name can change, but we'll just say for the purposes of our analogy that he's always going to be Caleb, which is pretty likely, right? So now I know how to communicate with him. And how did I do that? I sent out an ARP broadcast. I said, I wouldn't say where's Caleb. I would send out a broadcast to everybody, which I did, right? I said it to everybody, but I looked at Caleb and he said, oh, I'm Caleb. And now we're able to communicate at the data link layer, which means we can communicate over the physical wire or wireless or whatever. So this layer is MAC addresses. And theoretically, MAC addresses never change, although of course we can spoof them. And you can change them in the operating system and all kinds of stuff. But for this representation, our MAC addresses never change. So ARP stands for Address Resolution Protocol. And if we bring up the ARP command here, which I can't remember the parameter. Oh, there it is. You don't need a parameter. ARP means that these are the people I know about right now. Right? I know about myself. I know about the server. I don't know why that's showing up twice, but it's the same one. So if I ping, let's see, let's try, what else do we have? Let's see, S1, S, there. So that computer's up and running. So I pinged it by its IP address, didn't I? So when I pinged it by its IP address, it did not, I don't know physically where it is. It's like if I say, hey, Caleb, where the heck are you? And Caleb says, I'm over here. Well, now I know his IP address. Yeah, my analogy is not great. But then how I found that out is I ARPed and I said, oh, there's Caleb right over there. And now I know his physical address. And then I can communicate. So you have to know, what we do is we start from names, right? So I typed in D1S1. D1S1 resolves to an IP address by what? How do we resolve to an IP address?
DNS
Mhm.
by
Yep.
IP address, we resolve name.
Yep. So from a name to an IP address, we use DNS. So now we know the IP address at this layer. Okay, and actually DNS, well, let me get up there, buddy. DNS is at this layer. It's it's an application. Let me get up there. Anyway, it's an application that allows us to find things. So now I know his IP address. Well, that's not helpful because I can't actually communicate. I don't know which wire to send my traffic on. So then my computer sends out an ARP broadcast and says, oh, well, here's the name, here's the IP address, what is the hardware address? And I shout that to everybody, which is a broadcast. And Caleb says back, here is my hardware address. Let's communicate. Now we can communicate because our cards know each other. I can send my packet from me directly to Caleb. And so how we're mapping the network with this is we're sending ARP broadcasts to everybody saying, who the heck is here? And we're getting responses from everybody on the network that's turned on, you know. And that's how we're scanning it so quickly. And we know everybody's IP address, we know everybody's MAC address. They could have set this up so it also resolved host addresses. It's also finding out, well, how does it know the type of devices that are out there? All MAC addresses are registered to a manufacturer or a vendor. So this is looking up in a MAC address database somewhere that all of these computers are manufactured by Dell. My server in the back of the room is manufactured by HP. Here's my Dell server. There's my access point up there, my Ruckus access point. So it identifies all these by looking up in a MAC address database. Because each of these ranges, this is the unique part of the MAC address. This part of the MAC address belongs to the manufacturer, the first three. So these three indicate Dell. These three indicate Express If, which is my little temperature thing in the back of the room, my little ESP thing. These indicate Dell. These indicate, well, what do you suppose this indicates? 54. Oh, this indicates a virtual machine usually, because that's what it looks like from the outside world, I think. Although I don't know why we're not seeing everybody else's. Huh. Anyway, there's my switch. Well, virtual machines don't always play by the rules. When you're done, you can type Q, which is very common for a utility that just sits there and does things. When you want to get out, you type Q. Yeah.
Where's the count and when?
That's how many times we've communicated with them.
Okay.
The length would be how long the packet is. So how much information it looks like, doesn't it?
Yeah.
So it looks like a single packet is 60. And then as you go through 6, so each time we communicate, it would give another one. I'm not sure why some we only communicate once and some we communicate with more. That would be the algorithm of whoever designed this program. And I'm 132, so I don't know why only one of us is returning this. I'm pretty sure that's what the virtual adapter looks like out on the internet. I mean, out on the network.
I see it too in the same IP address. PCS System Technic GmbH.
Yeah.
I don't know. Yeah, I'm just getting 54. It's the only one I'm getting.
Yeah, I'm getting the same.
But we all are doing the same thing, so I'm not sure why it's not responding the same way. But it looks like we're getting all the physical machines in the room. Well, maybe not, because I don't think they're all turned on. I think I had them all turned on earlier. Oh, here we go. If you cursor down. Yeah, I did. And here's somebody else's at 140. Yeah, if you cursor down, I forgot. I turned on all the computers today so I could have them do updates. Yep. So there we go. I have no idea what Cloud Network Technology Singapore is. Is that you hacking my network, Philippine?
No.
You're trying to get an A in the class? I don't know what that is. This Intel Corporate is probably somebody's wireless on their laptop, is my guess. Because all these would be our computers. And quite often when you're doing a scan of the network, you're not going to see the address of the computer that you're scanning from. So I'm not going to see my virtual machine from this. Well, there was a lot to learn in there that you're not going to just get from doing the assignment. So now something else we're going to look at is redirect. So this is wonderful to have it on the screen. But what if we want to So this has to do a standard input and standard output. The standard output for like command line interfaces is the console. But we can redirect that output to a file. So when I run this command, it's going to redirect all that output to this text file, and then I can take a look at it later. I don't remember what -p does. Yeah, I'd have to look it up.
It says print results in a format
Ah.
suitable for parsing by another program
Yeah,
and stop after active scan.
that makes sense. So after the scan is finished doing its active part,
Yeah,
it'll then print it to the console, which in this case, with our greater than sign, we're redirecting it saying, go to this file.
mm,
And so since we've said, do it in a format that looks pretty, and we're redirecting it, it doesn't show up on our screen, does it? Which that's fine.
it doesn't, yeah, that's
We
perfect.
just want to be able to see it here. So if I bring up my favorite editor, Nano, there we are. And then look at it later. So we have a baseline for all the computers that we scanned this time. And then we can scan again tomorrow and see if that baseline changes. And then we can scan again the next day and see if the baseline changes. That's one of the ways that you help protect your network, is doing scans at various times and see what changes. Because if somebody's trying to muck with your network, they're not going to put up a sign that says, hello, I'm mucking with your network. You have to keep track of things and see what's changed. Like, oh, look right here. We have an unknown vendor. Again, I think that's Philippine trying to get into my network.
I don't even have a computer.
I wonder what this one is.
Oh,
Cloud Network Technology Singapore. It
that's
could just
weird.
be
I
a
don't-
wireless.
I don't see that guy as well. I don't see.
So maybe that's your wireless adapter?
I don't
120?
don't see it. I don't see it in my list.
So maybe
Wow.
that's your wireless card,
Maybe.
possibly.
I cannot see myself.
Typically, when you're scanning, you can't see your computer.
Oh, what is the MAC address there? Cloud AC
C-50-DE,
50DE?
E. It may not. It may be somebody else's laptop.
No, I have, where is mine? Mine is FC7774.
Okay, so that's not you. It's FC.
And my IP is 118.
Yeah, and I'm not seeing you in my scan either, your laptop. It may be that your laptop has a firewall set up to prohibit me looking at stuff.
Yeah, my IP is 1001 and 118.
Yep, and so it's not showing up in my scan. Is it showing up in anybody else's? 118? Yeah, so you're not always,
1001, 118. This is me.
oh, and I don't have my old scanner. So advanced IP scanner is an open, like not open source, but it's a freeware little scanner that's not a bad thing. It works just fine. Of course, trying advertising things. That's a very lightweight scanner. Takes very little time to scan your network. I use it a lot. So we'll see what we see from here. I mean, it looks suspicious, but until they put something suspicious in it and I tell people to use it and then you're being hacked. Nothing is suspicious. Nothing is safe until it isn't. All right. So this is what we found from Netdiscover. And where did my program go? Try it again. There it is. So notice this guy picked up the two network ranges that my machine is talking to. Does this look like my local network right there? 10.0.1.1 through 254? Does that look like the local network in this room?
Yes.
It's another way of saying I want to scan all these IP addresses. Does anybody know what this one is? 192.168.56?
We don't want it, I think.
Yeah, if you don't know what it is by now, I've like put this in every assignment. This is the not loop back, but it's like the address that VirtualBox uses internally to connect with your network card. So really, that's all it is. We never use it for scanning or anything. We will never use that address for anything ever. Except for saying that's an address we're never going to use. And so this will scan, it'll come up with the IP address, you know, and all this stuff. Oh, see, now I'm finding Cali Phil. Because it also has in it, its scanning algorithm, it's also resolving IP addresses too. And so you can see it does it fairly quickly. So it's a quick little scanner. And 3244 alive, 34 alive means we're probably finding it. Oh, it's Nick. Nick's hacking my network. That's your wireless adapter. And there's Cali Bill and Cali Caleb. Yeah.
That would make no sense.
And there is no 118.
No, you must have something that's preventing us seeing you on the wireless. It could be, I don't know. Because the stuff, this is probably using ARP and a ping scan. Because it'd have to almost use a ping scan to do the resolution for the DNS, you know. So you have something on your laptop that makes you very sneaky and secure, right? So you're hacking my network. I don't know. Probably something to do with, it's probably not something you set up. It's just probably part of the